Hey guys, we're doing this homework problem from our second section of homework, and what we got here is a 100-pound load and these three cables attached to it. Now, what we got to do here is use the fact that the cable itself, the length of the cable, is what we'll find first in the direction of the cable. But then once we do that, we're going to scale it down to a unit vector, and once we find the unit vector, we're going to use the fact that all three of these combine to a 100-pound load on there, and we'll be able to come up with the force vectors with a little system of equations. So the first thing we need to do is just get the direction of these three vectors. So I'm going to call this one over here V1, this one back here V2, and this one back here V3. Alright, just working left to right. It doesn't matter which one you call what. But let's first of all find the direction for V1. So V1, we went from 1 negative square root of 3 and 0 to 0, 0, negative 2 square root of 3. So that means that that vector that gets us there is 1 square root of 3. Alright, this and this combine again to a 0, and then the 0 down to negative 2 square root of 3. So there's that vector. And then I'm going to do the same thing to get V2 and V3. Alright, and now I'm going to find their magnitudes. And the reason I'm going to find their magnitudes is because, again, I have to scale them down from the vectors that we're figuring down to that unit vector right here, and then we'll figure out what the force is on each one of these. So that's the direction that that cable is hanging. The magnitude on that thing, we square each one of these. So 1 squared plus 3 square root of 3 squared plus 12. So 1 plus 3, and this is all square root. 1 plus 3 is 4 plus 12 is 16 squared. That's 4. Alright, now if you look, all of these are going to have that same thing if you go underneath the radical. So there's a 4 and then a 12, that's a 16, so that'll have a magnitude of 4. And then other than signs, vector 3 and vector 1 are identical, so that'll also have a magnitude of 4. So all three of these vectors are magnitude 4, so that means actually find unit vectors in this direction. I just need to multiply all of these by a fourth. So if I multiply each one of these vectors by a fourth, then I have unit vectors in the direction. And I'm going to change them from V1s, V2, V3 to U1, U2, U3. Okay, so those are unit vectors now. They all have magnitude of 1, and they're pointed in the direction of the original blue vectors that were V1, V2, V3. Now, what do we know about these three vectors? We know that when we add them together, they and multiply them by the tensions that are on those, then we end up with a 100-pound load. So all of those together have to add up to this 100-pound load. So what we can do is represent the force. This is just like the distance that this thing is hanging down. But the force that's hanging down on this thing, if we go, that vector right there would be, if I'll call it F. F is the vector 0, 0, negative 100. So these vectors now, all of them, when I'm multiplying by the tensions that are on each of those cables, have to add up to that 0, 0, negative 100 vector. Okay, so what I'm going to do now is multiply each of these vectors by a scalar representing the tension that's acting on that cable. And those things have to add up to this F vector, this force vector. So what we're basically doing is we're multiplying the vector that's pointing down in the direction of, well, from here down to there. We're multiplying that by these unknown tensions. So on that cable that's pointing in that direction, there's this tension, so we're going to call it T1. And then we're going to add that to the second vector that's pointed towards the load, and there's a second tension that's acting on that, and then the third vector that's pointed towards the load, and there's a tension acting on that, and they all add up to that 0, 0, negative 100 force that's hanging down in the middle. So we're just going to substitute in, basically multiply these things by T1, T2, and T3, the original vectors, and then we'll have several equations in terms of these unknown tensions, and those are going to be our unknowns in our system. So u1, just to show you, I got 1/4. I'm basically going to multiply this vector right here by the t1. I'll just show you kind of what that looks like. So the first thing I'm going to do is I'm going to reduce these. I'm just basically multiply this 1/4 in, just so you can get the simplified form of these unit vectors. So I got the first one, t1 is going to be multiplied by the vector 1/4 square root of 3/4 and negative square root of 3 over 2. Alright, so that vector u1, I'm just replacing it. Alright, I'm replacing u1 with actually what it is. And if you look, we got 1/4 times the negative 1. I swear, oops, that should be a negative 1/4. And then 1/4 times the square root of 3. That's the square root of 3 over 4. Alright, and then the 4 and the negative 2 reduced to a negative 1/2. And then negative square root of 3 over 2. So that's where that's coming from. And then if you do that with the other two vectors, you can verify that that's these other two equations here. For t2, 1/2, 0, negative square root of 3 over 2, t3 times negative 1/4, negative square root of 3 over 4, and negative square root of 3 over 2. Now, what are we going to do with those? Well, just look and interpret. So that means that these three things right here, this times t1, this times t2, this times t3, have to sum to that first 0 from this guy. So that gives me this first equation, negative 1/4 t1 plus 1/2 t2 minus 1/4 t3 equals 0. That equals this 0. And then likewise, 3/4, or sorry, square root of 3 over 4 t1, 0 t2, negative square root of 3 over 4 t3 adds up to the middle 0. Okay. And then the last one, they're all, notice this last one, they're all negative square root of 3 over 2. So negative square root of 3 over 2, negative square root of 3 over 2, negative square root of 3 over 2. And those are all, I just pulled that out, and then you add them all together. Those all add up to negative 100. So there's our system. Now we have to solve this and have exact values, so you have to be careful with that. But the first thing I see is this t1 and t3 in this middle equation here. And there are, have the same coefficient, and the middle coefficient is 0. Alright, and it has to add to 0. So since they have the same or opposite coefficients, and t1 and t3 are the only variables that are going to contribute to the sum, it has to be that t1 and t3 are equal to one another. So I do know that at least t1 equals t3. Okay. Now, since t1 and t3 are equal, I can make use of that down here on this bottom equation. I'm going to multiply both sides by this negative square root of 3 over 2, the reciprocal, to get rid of it. And t1 and t3 are equal, so I can say that 2t1 plus t2 equals, and if I multiply both sides by 2 over the square root of 3 and negate it, I will end up with 200 divided by the square root of 3. Alright, so I can say that t2 equals 200 divided by the square root of 3 minus 2t1. Okay, and then the top equation, I got this guy right here. I'm going to multiply through by 4 to get single coefficient. So if I multiply through by 4, I would have negative t1 plus 2t2 minus t3 equals 0. Alright, and then using the stuff that we've found out, t1 and t3 are equal, so again this is negative 2t1. And then 2t2, well t2 is this, so 2 of those, so I got negative 2t1, there's a 400 over the square root of 3 minus a 4t1, and now I just combine and do a little algebra. So I get t1, or 6t1 equals 400 over the square root of 3, so divide by 6, so you get 200 over the 3 square root of 3, rationalize 200 square root of 3 over 9 is what we get for t1, which is also what's equal to t3. Alright, now we're going to use this equation. T2 equals 200 square root of 3 over, or minus 2t1, so 200 square root of 3 minus 2, we just got t1. I'm using this form of it because of the denominators. So that's 200 square root of 3 minus 400 over 3 root 3. Alright, and then to get a common denominator, I need to multiply this by 3. So I multiply this by 3. So I get 600 minus 400, which equals 200 over 3 root 3, which should make sense that they all end up being the same. So T1 equals T2 equals T3. They all end up being the same because of the picture that we had to begin with. That kind of a regular tetrahedron that's being formed there. So there's our tensions, and then you take our tensions and you multiply by these vectors, and you can get the unit vectors, and you can get the actual vectors there. Alright, so this was the unit vector in that direction. There's T1. So just to get you started, if I multiply 200 square root of 3 by that negative 1/4, I'm going to get that first force vector is going to be negative 50 over 3 root 3. Alright, and then the same thing. 4 and the 200 will go into one another, and I'll have, and the 3 root 3 will reduce, and I'll have 50 over 3. And then the same thing here. The 2 will go into 200, that'll give me a 100. 3 root 3 will cancel. So I'll have 100 over 3. So there's how you do it. And just multiply the T1, T2, T3 by those 3 unit vectors. U1, U2, U3. And you'll get these. The T1, T2, T3 are just scalars. They're rescaling this thing to be a force rather than just a unit vector in the direction of those cables.